What's up? Welcome back. This is day 15 of the Advent of Code. We're solving this with Ruby. This one's called Beacon Exclusion Zone. This is for 2022. And the idea is that we're going to have some sensors and some beacons. That's our input. And we're going to have this grid where we'll see where the sensors are placed and where their beacons are placed. And every single sensor has a beacon that is associated with it, and the distance from the sensor to the beacon will create like a range around that sensor. A sensor can have at most one beacon in range, and it'll be locked onto that beacon. On a given y-axis, along one of these rows, we need to figure out whether or not beacons can exist in that row. So for this part of the example, we're just seeing all of the pound signs are where it's impossible for a beacon to exist other than the beacon that this one sensor is associated with. Okay, the output is going to be the count of the positions between 0 and whatever the max is, or between some negative minimum and whatever the max is. This is all of the positions where a beacon cannot exist. So how many positions can not contain a beacon? So we're going to go through and figure out this part one. Okay, so we'll open up day 15, and at the bottom of it, we're going to drop in our example input, which looks like this, and we'll work on parsing that. I'm going to use regular expressions to look at each of these lines and pull out the numbers for where the sensor exists and where the beacon exists. And we're going to then store all of this into a couple of sets, and then we'll use those to iterate over and check against the sort of the diamond around the sensor and whether or not other beacons might exist at those points. Okay, if argv is empty, then data is going to be data.readLines out any new lines at the end. Otherwise, data is going to be read from a file. Okay, we'll just iterate over data. We'll say data.map, and this is where we're going to extract out the X and Y coordinates. We're going to actually map onto matches. We're going to create a regular expression based on one of these inputs. So just grab that whole thing and create a regular expression, and we're going to match on the line, the first argument to the block. This is hard to see. Yeah, we'll zoom in here, and instead of the value 2, we actually want to have some capture group that's going to give us the value of X, and this is going to be a digit potentially. Now, it is also possible that this is negative, so we also want to have the potential or the optional negative in here. We'll grab this same thing and we'll paste it in for all of the different numeric values. Okay, and so now it looks something like this. Obviously, we can't have multiple lines here in our regular expression, but so that you can see, this is what we're doing. We're checking to see, or we're going to get a match for X, a match for Y, and then the closest beacon is going to be BX, and then BY. Okay. And then what we want to do is we'll call .map again, and this is going to give us our match. And now we're going to say something like X, Y is equal to match at X, match at Y, and then our beacon X and beacon Y is going to be our match of beacon X and beacon Y. Now, these points here, we actually want to add them into some sets. We'll say this is like our sensor, and this is going to be our beacon, and we're going to have sets of sensors and some sets of beacons. So I just learned that if you're in Ruby 3.2, at least in preview 2, you don't actually need to require the set gem. I don't know if that's going to be long term. Okay, for now what we can do is say sensors, we'll add in the sensor, and beacons will add in the beacons, and let's just print out sensors, and we'll print out beacons, and we'll see what we get. So we say Ruby day 15, there is no match. Okay, let's see if why we're not matching. Okay. And is that because, oh, we have a bunch of new lines here at the bottom that are just garbage. Okay. All right, so now we have two sets. One is our sensors and one is our beacons, and we're looking good. This is super messy. So let's just clean this up a little bit. And we actually don't need a map here. We can just say like dot each. And in fact, we don't have to do anything fancy here. We can just say match equals this thing, and we should be good. Okay, same answer. All right, now every single time we encounter a sensor, or even as we're parsing this, we need to figure out what the distance is between the sensor and its beacon. And that distance is going to be important because that distance defines like the radius almost around the sensor where there cannot be any other beacons. Let's say that the D is some distance from the sensor to the beacon, and we'll define some function here called distance. And that's going to take in A and B, and it'll just return the absolute value of the X for the first point minus the X for the second point plus the absolute value for the Y of the first point minus the Y of the second point. And that will give us the distance. This is like the Manhattan distance thing. There was a link to describe how this distance works on Wikipedia. So if you're in the Advent of Code instructions, you can head over and check that out. What we want to do is actually, as we're collecting up our sensors, we're going to include the sensor and the distance. Our set for sensors will be a set of arrays where the first element in the array is the sensor and the second element is the distance from the sensor to the beacon. And that'll allow us to do some math around ourselves. The first thing that we want to do is iterate over a huge range of values. And as we're going over those values, we need to check every single point on a given row of our grid and detect whether or not that point is closer to our sensor than the beacon is to our sensor. And that'll tell us whether or not it's allowed to in range. I'm going to start from like negative 10 million to 10 million dot each. And this is going to be our like X value, and the Y value for the example case is 10. So we're going to just grab, I'll set Y equal to 10 in the case that we're running the example input. Then we get these points, and a point is equal to X and Y, right? So because Y is fixed, we just have the row 10, and then X is going to be like every single point on that row from negative 10 million to positive 10 million. And we want to check and see which of those points are not beacons because they're within range of a sensor, and they're also not beacons themselves. In order to figure this out, we need to go over each of the sensors. For each sensor, we're going to get sensor and the distance to the sensor. And if the distance from the point to the sensor is less than D, and again, D is the distance to the beacon, then it's not allowed. Excluded is going to be some new set. We'll add that point into the excluded, and then we'll break. Okay, we're going to iterate over all of the sensors. Actually, I don't know if we need this break. So then we'll p excluded.size. Running the code for the solutions for day 15 takes a long time. In this video, I'm going to speed up a bunch of those while we're waiting, but just know that in Ruby, even in a lot of other languages, some solutions that I saw in Python, they're not fast. I'm sure it's way faster if these are written in something like Rust or C++ or something, but as they stand, when they're written in Ruby, they're not super, super fast, which is fine because we actually find the answer that we need in a somewhat reasonable time. This printed out 23. That is the points that are excluded, which is not right. It cannot be excluded if it is also already a beacon. Let's look at the instructions again. How many positions cannot contain a beacon? So if the distance is less than D, then it's excluded. If it's not, if the beacons don't include the point either. Let's see what this gets us. The fact that it gave us 23 makes me think that it's off by more than just a little bit. Okay, I wonder if this is actually less than or equal to, because it can be, or even if it's the same exact distance to the beacon, then that also is excluded. It cannot be exactly the same distance to the... Okay, so this is the correct answer for part 1. So now what we want to do is grab our input, grab our test input, which is here. We're going to grab our puzzle input, grab all of this, paste it in, and then run Ruby day 15 input. There's one other thing we need to do though. When we're running against our file input, instead of using y equals 10, we use a different y value here. So consult the report of sensors. Okay, so in the row where 2 equals 2 million, or y equals 2 million. So here for y is equal to 2 million for our actual use case. We'll run this. Okay, so we got some input. Let's check and see if that is correct. All right, so that was our puzzle answers. That is part 1. So we have figured out part 1. This problem is particularly challenging. And so if you're following along and you finish part 1, excellent job. And we'll jump into part 2 shortly.